We're going to think about data archiving and sharing in the context of the FAIR principles, which were developed to provide general guidance about effectively sharing research data. The FAIR principles stipulate that the data must be findable by search and through a unique ID, accessible in a repository, interoperable with data of the same type, and reusable by having proper metadata and a license for reuse. We're going to step backwards through the FAIR principles to illustrate the fact that most of the work required to be fair is completed by archiving the data for yourself. Let's start with reusability. To make the data reusable, we need metadata to put the data into context, file formats that can be opened in the long term, and rules for how the data can be used in the form of a reuse license. Depending on how old you are, you may recognize the picture on the right as a floppy disk. If so, when was the last time you used one? Do you still have the hardware to read one of those? Just like physical formats, electronic formats can go stale and unusable. To increase the odds that your data will be usable into the future, avoid proprietary formats. Companies that own these formats can change them at any time, rendering old versions unusable. It's the file equivalent of not having a floppy drive anymore. Another good rule of thumb is to use data formats that are common for your field to increase the chances that software will be available to read the files. An example of a good format for tabular data is a CSV file. It's a text-based format that's non-proprietary, but can as easily be read into a spreadsheet program as it can to a programming environment like RStudio. Using Excel spreadsheets during the research process is easy and convenient, but it's even more convenient if you follow some simple guidelines that will make your data easier to preserve later. First, include only one table per sheet. Also, make these sheets CSV friendly by not including formatting, images, or formulas, or at least making them so that they're easily removable. Finally, it's important to make your data tidy, which means that every column is a variable and every row is an observation. You can find out more about making your data tidy by going to the workshop materials listed on this slide. One way to get Excel files into archival formats is the Excel Archival tool, created at the University of Minnesota. It takes an Excel file as input and separates the content into three non-proprietary formats: a CSV for each tab, a text file containing any formulas, and an HTML visualization of what the original spreadsheet formatting looked like. Let's take a moment now to do a quick exercise. Think of one type of data that you produce. What format is it in? Is the format proprietary? If so, what alternative format could you use? Is it the most commonly used data format for that type of data? At this point, feel free to pause the video for a moment and answer these questions for yourselves before moving on. Now that you know what type of data files you're going to produce, you need to start thinking about how to document your data and what to do with it. Data documentation is generally referred to as metadata, or data about your data. This includes all of the information that someone else, including your future self, would need to understand your data as well as the analyses you've performed. Let's talk about some common metadata formats. One really common variety of metadata is a README file. README files contain information about where the data came from, any restrictions to reuse, how to cite the data, an inventory of data files, and descriptions of what is in each of the files in your inventory. There are many other things that you can put in a README file too. See the README checklist file linked on this slide for more ideas. In order to encourage others to cite your data properly, it's a good idea to include a suggested citation in your documentation. You can also cite your data as a reference in any associated publications. If you're working with data in a tabular format, a codebook is another very useful piece of metadata to include. Codebooks have a row for each variable or column header that you have in your table, and columns for information like variable names, the type of variables, a description of what the variable measures, and what units and values are acceptable. It can also specify what codes you use for missing data. If you work with data in Excel, there's a free add-on called Collectica that allows you to easily document information about your variables and export a codebook with the click of a button. Some statistical software programs like SPSS have this functionality built in as well. Another type of research output that you'll want to plan for is a record of your data analysis, ideally the code or syntax used to clean and analyze your data. This ensures that your results are reproducible, which is important both for yourself if you plan to run the same analyses on multiple datasets, and for the integrity and transparency of your research so that others can understand and repeat what you did, coming up with the same results. For more information about strategies to make your research reproducible, see the workshop materials linked at the bottom of the slide. Other types of research output that you might need to plan for include research software that was produced, lab protocols, measurement instruments such as questionnaires or interview scripts, and consent forms demonstrating permission to share data if you're working with human participants. Beyond sharing data and code together, there are also tools for sharing the computing environment necessary for code to function, such as electronic lab notebooks like Jupyter Notebooks and containers like Singularity and Docker. PackRat is a tool for bundling all of your packages and dependencies in R, and Binder is a way to share your data, code, and interactive computing environment in a browser. These kinds of tools are still relatively new, but they're becoming increasingly used by researchers as the importance of computational reproducibility continues to grow. The last consideration that I'll talk about for making your data reusable is licensing. Licenses allow you to state your provisions for other people to use your data, typically things like citing either the dataset itself or an associated manuscript. Creative Commons licensing is a good starting point in general, but in the United States, data isn't copyrightable, so it's probably best to apply a CC0 license to put your data in the public domain. Now let's talk about interoperability. This provision allows your data to be combined with other similar data from meta-analyses. This is where community standards come into play. To facilitate interoperability, we need comparable metadata and data formats. Data and metadata standards can be generic or field-specific. Generic standards can describe anything. Generic metadata contain information like title, authors, keywords that can apply to any dataset. Generic data formats like tabular CSV files can contain a variety of data types. Discipline-specific standards are more tailored to the discipline and ask for more specific information. To see if your field has a data type or metadata standards, the Digital Curation Center and Fair Sharing are good places to search. Here are some examples of commonly used disciplinary metadata standards.